Yeah, hi. So here we are into the next chapter, which is a statistics refresher, um, but from the context of market research. Now, I know you all are studying data science, and you will have a great degree of familiarity with concepts which are considerably more advanced than what we're going to cover here. So this is strictly a refresher. Uh, and I am going to try and not be too mathematical because, as I keep stressing, the focus is on understanding just enough to do good market research. The focus of this particular paper is not to make you a statistician, right? Having said that, let's go forward with the most basic concepts. So, these are the cover topics that we will cover here: measures of central tendency, mean, median, mode, which is as basic as it can get. Measures of variability, standard deviation, variance, and range. We'll talk about two or three extremely important concepts for market research: normal distribution, sampling distribution, central limit theorem, and maybe one line about what a frequency distribution is, right? So, without further ado, let's go on. Here we are in the mean. So, what is the mean? The mean is the mathematical average, the mathematical average of the set of figures. For example, if we take these 10 numbers here, right? So how do we calculate the mean of these 10 numbers? We take 45 plus 35 plus 38 plus 1 plus 59 plus 54, etc., etc., up to plus 145. That gives us a total of 618. We divide it by 10 and we get a mean of 61.8. Any issues here? Do we want to work out an example? Or
No, this is clear.
this is clear? So let's go forward. The median is the next one. Mm, the median is the middle value, right? So when we say something is a median, we can confidently say that 50% of the values are above and 50% are below because the median is the middle value. So you first have to arrange all the numbers in decreasing order or increasing order and then take the middle value. Now, let's take the same 10 numbers that we saw earlier. In increasing order, they are 1, 35, 38, 45, 54, 59, 73, 79, 89, 145. Right? So, now what is the middle here? When there are 11 numbers, the middle is 6. When there are 3 numbers, the middle is the second one. When there are 15 numbers, the middle is the eighth one. But here there are 10. Therefore, there is 5 and 6 as the middle numbers. So there are 4 this side, 4 that side, right? So there's no one median here. There are two median values, really speaking. So we will take the mean of those two, which is 54 plus 59 by 2, that is 113 by 2, that is 56.5. Interestingly, the mean was 61.8, the median is 56.5. They're not that different from each other. Can you tell me why?
Because there isn't too much of difference
Between the
the values.
sort of, it's not an exact answer. The exact answer is because there are no extreme outliers here. Okay, we'll see an example of that also. But this was what median is clear. So if there was 11th value here, which is just for example 62. So then all order would have changed. This would have become 11. This would have become 10, right, and so on and so forth. Then what will the median be?
59 would be the median.
Excellent. The sixth value, 59, would be the median. Yes, perfect. Yeah. You have understood the concept. Yeah. Let's go forward. The mode is the third one. Mode is the figure that comes most often in the data set. Okay. Now, in our earlier example, Can you go back one slide? None of those values come more than once. So actually there's no mode. So we have created another example here. Here the 10 numbers are 75, 79, sorry, we have to go back up. Here the 10 numbers are 75, 79, 83, 87, 89, 75 again, 113, 112, 113 again, and 75 yet again. So 75 comes 3 times, 113 comes 2 times. All the other values come only once each. Therefore, the mode here is 75. Right? But it's not really a good mode. I mean, when I say good mode, there's nothing called good or bad. It's just a way a market research would talk. It is not a good mode in the sense it is only 3 times out of 10. It is not that it comes 8 times out of 10 or 7 times out of 10. And the other values could be very, very different. Therefore, mode is indeed useful in certain situations, and we will come to those situations as we go along. But in most practical situations in market research, we use more of mean. Okay, neither the median nor the mode is used very much. They have specific applications, but they don't have wide applications. Okay, having said that, I will, in a very indirect way, we always use mode, but and we'll talk about that. One more slide, and then we'll come back to the slide. Mhm. Yeah, sorry, go back here. I've jumped the slide. This is where we, yeah. So, in any kind of market research study, we do things like, which brand you use most often, right? And so the brand that they talk about, the percentage of people mentioning this brand, that brand, that brand, whichever percentage is highest is actually the mode. So we look at the data, we analyze the data, but we don't consciously call it the mode, right? So we use the mode in a very, very indirect way. But we don't use the mode as the mode. Reason being, we very rarely get a good mode, 8 out of 10 or 7 out of 10 or 65 out of 85 options and stuff like that. I hope this logic is clear about why we don't use it. Mean is a much more commonly used measure in practical market research, right?
Just to clarify what I've understood, so you're saying in a frequency distribution, the number of the count or number of the sum of a class interval or a
You're using
action.
words which we haven't talked about, but yeah, please go ahead.
So the highest number that would be the mode. That's what you're saying, right?
Yes. So you used a word called frequency distribution. You use a word called class interval. What do you know about these two words? Interesting that you raised it here.
A frequency distribution is a table which gives the summary of the counts of each value that occurs in a.
Yep. So, for example, which brand of soft drink do you drink? Uh, Coca-Cola, right? 3 people out of 10 drink it. Pepsi, 2 out of 10. Thumbs up, 4 out of 10. And Mirinda or whatever, 1 out of 10. This is a frequency distribution, right? Excellent. What's the class interval? I'm not surprised that you know this. I mean, you're BSc data science students, but nonetheless, yeah.
Class interval is, let's say you want to understand uh, which age group people belong to, and you want to divide
Excellent,
them under
excellent,
different
excellent.
headings.
Can you give me a blank slide? So you're taking a very good example. So let's say we're asking what people's age. That's a survey question. So there are some people who are 19. There are some who are 20. There are some who are 22. There are some who are 21, 23, 24, etc., etc., etc. Let's say 5 people are here, 10 are here, 3 are here, 15 are here, etc., etc., etc. Right? what you do in a class interval is you group them. So you say, for example, 19 to 23, 24 to 27, 27 to, or 24 to 28 would be appropriate, 29 to 33, 34 to 38. So here there are 18 people, here there are 22 people. This is class interval, correct?
Yeah, the gap between
Yeah,
every
excellent. Excellent, excellent. So the groups that you create a class interval, this is also a frequency distribution, isn't it?
Yeah.
And these are the class intervals. Excellent. So what is the mode here in this example?
It will be 29 to 33.
Excellent, because there are 29 people there. So the mode is equal to, mode comes in the 29 to 33 interval. So what's actual mode? There is a mathematical formula, right? But very roughly, we can take the mode as 31.
Right.
Nothing very wrong with that. Okay.
So the midpoint in that.
Very roughly, strictly speaking, it's not correct. But then again, we come back to statistics versus market research. For market research, we'll take it as roughly the mode is 31, around 30. It's a good enough way to look at it. So the modal age group is 29 to 33 is the way we talk. We don't say mode. We say the modal age group in our sample survey is 29 to 33. That's the way we talk. Is that okay?
Yeah.
Right. So let's go forward. Now, the median, as I said, we don't use it very often, but there are situations where the median becomes more relevant than the mean when there are extreme points or what is known as outliers. Now, let's look at this data. This is our original set of 10 numbers, which had a mean of 61.8 and a median of 56.5. Now, let us say the last number alone is changed to 712. Now, this is very far away from these other numbers. It is an extreme point, it's an outlier. So the mean now becomes 118.5 because an extra 500 points or 500 numbers somewhere here, and that becomes an extra 50 something in the mean. But the median is still these two numbers. The median remains 56.5, it's the same. So the point is a median is not affected by extreme values. And that is when you're measuring a variable which tends to have extreme highs or extreme lows for a small percentage, but the vast majority is still in the bulk, the median becomes a very useful measure. Right? So you've understood mean, median, mode. This is the ABC of statistics. Now we'll go on to D, E, and F. Right? We'll go to something called measures of variability. So let us say there are these three sets of numbers. This is set 1, this is set 2, this is set 3. So this is 40, 40, 40, 40, 40, 40, and the mean is 40.0. This is 43, 31, 47, 35, 38, 42. The mean is still 40.0. This is 6, 109, 23, 72, 41, 5, 8, 88, 5. The mean is still 40.0. All of these have the same mean. But this one doesn't vary at all. This is like a straight line.
Yeah.
This varies a bit. This varies wildly. Right? Now, we need to measure this variability. Okay? If you're a cricket follower, you can think of this as scores. One batsman keeps on scoring 30, 40, 35, 40. He's very consistent. Other batsman scores 150 this time and duck the next time. It's very inconsistent. But the batting average may be the same. Now, who is better, who is worse is a subjective decision. We're not going there. We're not saying this number set is better than that number set. But we do need to measure how much, whatever we are measuring, whatever survey we're doing, how much the data is consistent across all the sample, how much the data varies across the sample. So we have certain measures of variability. You understand why we need measures of variability? We need to quantify. It is intuitively obvious that this data has much more variability than this data.
Yes.
However, is there a way we can quantify it? And that's what we'll see now.
So the extent to which there is a difference
Yes.
between values.
Yes, exactly. Right? So the simplest measure of variability is something called range. The range is simply the highest value in the data minus the lowest. Now the range for this data set is 0. Because the highest is also 40, the lowest is also 40. The range for this data set, the highest is 43 the highest so far, 47. 47 is the highest. Lowest 37 so far, 35 so far.
35.
35 is the lowest. So the range is 47 minus 35 equal to 12. Look at this. There's only one number with 3 figures. So there is 109 is the highest. The 6 is very low. 5. 5 is the lowest. 109 minus 5 is 104. So the higher the range, the more the variability. Right? So again, if you follow cricket, to understand this better, a batsman scores 352 today and a duck the next day. His range is 352. But if a batsman in his career, he never scores a duck, his minimum score is 8 and his highest score is 95. His range is 95 minus 8, which is 87. Now, which is better? We're not going there. In some situations, the batsman who scores 95 highest is better. In some situations, the batsman who scores 350 is better. That's not the point of this discussion. The point is we have managed to quantify which data set has what variability. So range is a very simple measure, but it's also a very crude measure. We need a more sophisticated measure, which brings us to what we call standard deviation. Yeah, can we go to the next slide? Yeah. So the most commonly used measure and also the most sophisticated measure is standard deviation. Again, let's learn this through an example. So we are using the same data set that we had earlier, 143, 37, 47, the one whose range was 12. The second data set that we saw in the previous slide. Mean score is 40. Now what we do, now these numbers, to save myself the trouble of searching in PowerPoint, I'm calling this, the way you refer to these is xi. So this is xi. X1 is 43, X37, X2 is 37, X3 is 47. So this is xi, X1, X2, X3, X4, etc.
X1 to X10.
Yeah. This mean is called X bar. That's the way we refer to it in statistics. Okay? So this column is xi minus X bar. So 43 minus 40 is plus 3. 37 minus 40 is minus 3. So on and so forth.
Now, all of this, it will come 0.
If we add all of this, it will come 0 because the plus and minus will cancel out. So we can't just add all of this. That looks like the variability is 0, which is not correct. Therefore, we have to remove the negative sign, we square it. So we do xi minus x bar square. So 3 square is 9. 3 square is 9. Sorry, minus 3 square is also 9. 7 square is 49. Minus 5 square is 25. And so on and so forth. So you have 9, 9, 49, 25. You have a sum of this, which is 136. Now we come to what is standard deviation. People refer to it differently. Most commonly used thing is sigma. In statistical formulae, we call it sigma. There are other ways to refer to it. Sigma is basically standard deviation is equal to xi minus x bar squared divided by n. N is the number of observations and square root of that. Okay, the whole thing comes into the square root. So this in this case is equal to square root of 136 by 10, which is equal to square root of 13.6, which I've already referred to it. I'm not just telling you, I didn't do the maths now. So, which comes to approximately 3.6 or 3.7 something. Is this okay?
Yes.
Is the formula clear?
Yes.
Will you be able to memorize the formula?
Yes.
You don't need to. There are calculators and computer programs that will give it for you. You need to understand the concept. The concept is that every value, how far away is it from the mean, which is xi by x bar? To compensate for the fact that some are more, some are less, you square it. Therefore, you have an absolute number, not a positive negative number. That absolute number total is the total extent to which the data varies from the mean. Divided by 10 is the average extent to which the data varies from the mean. But since you put a square somewhere, you're going to put a square root to bring it back to the same unit of measurement, which is why sigma is a square root of xi minus x bar squared divided by n. Remember, the square root starts from here.
Right.
This is clear now? Shall we do one more example?
Yes.
Okay. So let's take the third data set where the mean was 40 and the range was 109 minus, sorry, where the range was 109 minus 5, 104, right? Say third data set which had wide variability. So 6 minus 40. So this is xi. What is this?
xi minus x bar.
Xi minus x bar. So 6 minus 40. So this is x bar, right? Is minus 34. 109 minus 40 is plus 69. 23 minus 40 is minus 17, so on and so forth. So this is xi minus x bar squared. So 34 minus 34 squared is equal to 1156 plus 69 squared is equal to 4761, so on and so forth. And the sum of this is 13018. So what is the standard deviation? It is equal to xi minus x bar the whole square divided by n. That is equal to square root of 13018 divided by n. That is equal to the square root of 1301.8. Right? Because divided by 10, sorry. So that is equal to 30 squared are 900, 40 squares are 1600. So there's somewhere around 35 or 36. This is square, this is deviation. Do you have a calculator?
Yeah.
Could you give me the actual number?
36.08.
Excellent. So what does this tell us? The previous one it was 3.7. So this data is much more variable than the previous data. It was intuitively obvious. The range confirmed it to us. Now the standard deviation also confirmed it to us. Right? So higher the standard deviation, the more the data's variability. Lower the standard deviation, the less the data's variability, more the consistent the data is. Is the formula clear? Is the application clear? Let's see one more example.
So at any given point in time,
Right.
you look at these. So you look at these figures and these individual figures 6, 109, 23, and so on and so forth.
Right.
And you say this is the standard deviation.
Right.
Would it be right to say that this would be plus or minus 36.08, the range of variability?
It is just an average measure of variability. So, for example, I mean, you're anticipating what we'll talk about later, but you can express 6 for example. No, 6 minus 40 is minus 34, which is equal to, approximately equal to the standard deviation. Correct. Whereas you take 109, 109 minus 40 is 69, which is approximately equal to 2 times the standard deviation. So you can express any data, any xi, in terms of it is 2 times away from the mean. There's 2 times the standard deviation away from the mean, or 1 time away, or 3 times away. That's one of the applications of this. Right? Yeah. Yes. Now, there is something called variance. Variance is nothing but the square of standard deviation. So variance is simply equal to xi minus x bar the whole square by n. That's all it is. Okay? Yeah, got the formula here. So in the two examples that we saw, example one, what is the variance?
0.
No,
This one, no?
no, the one with the first example for which we worked out standard deviation.
Oh, it is 3 point something square.
Yeah, is there a simpler way?
13.6.
Excellent. And the second one is?
Second one is 1301.8.
Right. So here it is, variance is simply 13 point, oh, sorry. Variance is simply 13.6. And this is simply 130.8 or whatever. You know, the number we got before we took the square root is the variant. Now let's go back to the example with this original data that we had. What is standard deviation here? There's no variable at all, so it should be 0. Can we cross check this mathematically? We should be able to, right?
Yeah, so 40 minus 40, 40 minus
So
40.
this xi, right? So xi minus x bar 0, 0, 0, 0, 0, 0, 0, 0, 0, 0.
So sigma all 0 is 0.
Absolutely. So logically the formula is perfect. Right? When there's no variability, the formula gives you a result of 0. Right? Okay, let us just go one more slide. Before we get to normal distribution, if you remember, I said you jump the gun and we talk about frequency distribution. Yes. So this is an example. We have asked, which brand of soft drink you like. Let's say 38% says they like Coke and 11% likes Pepsi, etc. Does the total add up to 100? 38% 11, 49, 63, 83, 100%. Right. So here the moral data point is Coke because 38% is the highest number here. So we keep using the mode when we study real life market research data. We don't consciously say, oh, now we should look at mode. We just look at the percentages and this is the highest, this is the lowest, and so on and so forth. Right? Okay. Let's take a quick break here and then come back to the normal distribution.